Hello guys, my name is Ritik Bhola and I am a founder of Inoopchem.com. So our today's topic is redox reactions part 1, which is a classical concept of reduction and oxidation. So today we will discuss about the general introduction of redox reactions, classical concept of reduction and oxidation, what is oxidizing agent and reducing agent, oxidation reduction reactions are complementary to each other. We will see how they are actually. Let's start with the introduction. As chemistry deals with the study of composition, structure, and properties of varieties of matter and the change of one kind of matter into another, and this transformation of one kind of into another is occurs through a number of different types of reactions, and such types of reaction are called are redox reaction. The term redox, in which RED represent the reduction reactions and OX represent the oxidation reactions. And these chemical reactions are accompanied by energy changes in the form of heat and in the form of light. Okay, so what is oxidation? Oxidation is a process involves the addition of oxygen or any other electronegative element, or you can define it as a process which involves removal of hydrogen or any electropositive element. Electropositive element, for example, like Mg plus 2, K plus, and if we're talking about electronegative element, for example, chlorine, Cl minus, fluorine, F minus, and many more. Okay, so now oxidation as addition of oxygen or any electronegative element. So in the first reaction, addition of oxygen takes place, in which magnesium and oxygen reacts to form magnesium oxide, in which oxidation of magnesium takes place. That means oxygen is added to the magnesium. That means oxidation of magnesium takes place. Okay, and the reaction is called oxidation reaction because addition of oxygen takes place. So now in the second reaction, addition of any electronegative element. In this reaction, magnesium and chlorine combines to form magnesium chloride. As we know, chlorine is an electronegative element. It combines to the magnesium and form magnesium chloride. That means oxidation of magnesium takes place, and here is the spelling mistake of magnesium. Now it is correct. This reaction is also oxidation reaction because the addition of any electronegative element takes place. In this reaction, The electronegative element is chlorine, Cl2. So now oxidation as removal of hydrogen or any electropositive element. So the first reaction is for removal of hydrogen. Okay, in this reaction, this is hydrogen sulfide and bromine reacts to form hydrogen bromide and sulfur. Okay, here the loss of hydrogen takes place. Okay, in this, hydrogen and sulfur are combined, and in this sulfur is alone. That means removal of hydrogens takes place, which means oxidation of sulfide ion takes place. The reaction is called oxidation because removal of hydrogens takes place. In the second example, it is a reaction of removal of any electropositive element. Okay, in this reaction, potassium iodide and hydrogen peroxide reacts to form iodine and potassium hydroxide. So potassium is an electropositive element and iodine is an electronegative element. So here is the removal of potassium takes place. That means oxidation of iodide ion takes place. Okay, so now what is reduction reaction? It is a process and it involves the addition of hydrogen or any electropositive element. Electropositive elements like Mg plus 2, potassium, and many more, etc. And you can define it as a process which involves removal of oxygen O2 and any electronegative element Cl minus, fluorine, bromine, etc. Okay, so now reduction as addition of hydrogen or any electropositive element. So in the first reaction, addition of hydrogens takes place. In this reaction, elementary nitrogen N2 and elementary hydrogen H2 reacts to form ammonia. In this, addition of hydrogen to nitrogen takes place. That means reduction of nitrogen takes place. In this reaction, hydrogen is bind with nitrogen. Okay, that means addition of hydrogen, reduction reactions takes place. In the second reaction, it involves addition of any electropositive element. Okay, in this reaction, stannous chloride and mercury chloride reacts, and their addition of electropositive elements takes place. As we know, mercury is electropositive element and chlorine is electronegative element. So here, one mercury atom adds. Okay, that means addition of mercury atoms takes place in this compound. That means reduction of mercury takes place. Now the reduction as removal of oxygen or any electronegative element. In the first reaction, it involves removal of oxygen. In this reaction, zinc oxide and carbon reacts to form zinc and carbon monoxide. And look here, removal of oxygen takes place. When they are reactants, zinc is combined with oxygen, and when it reacts with carbon, zinc is alone here and oxygen form bond with carbon to form carbon monoxide. That means reduction of zinc oxide takes place. In the second reaction, removal of any electronegative element. In this reaction, ferric chloride reacts with hydrogen to form ferric chloride and hydrochloric acid. As we know, iron is an electropositive element and chlorine is an electronegative element. So here, removal of one chlorine atom takes place. Look, there are thrice of chlorine and there are only twice of chlorine. That means one chlorine atom is removed from FeCl3 and it forms FeCl2. That means reduction of ferric chloride takes place. Now, what is oxidizing agent or oxidant? An oxidizing agent is a substance which supplies oxygen or any electronegative element in the reaction, or you can define it as it removes hydrogen or any electropositive element from the reaction. It is very important to note here that an oxidizing agent, after carrying out oxidation, itself reduced in a chemical reaction. For example, a reaction is given in which magnesium and fluorine are combined to form magnesium fluoride. Now recall the definition of oxidation, which is addition of electronegative element. So here fluorine is electronegative element and magnesium is electropositive element. So when fluorine combines with magnesium, it is called oxidation. Now it formed the product, which is Mg is electropositive and the addition of electropositive element is called reduction. So at the same time, fluorine oxidized and reduced. So fluorine is a oxidizing agent. After carrying out oxidation, it is reduced in a chemical reaction. There are more examples of oxidant are oxygen, chlorine, fluorine, manganese dioxide, hydrogen peroxide, potassium permanganate, potassium dichromate, nitric acid, and etc. Now, what is reducing agent or reductant? So, a reducing agent is a substance which supplies hydrogen or any electropositive element in the reaction. Whereas you can also define it as it removes oxygen or any electronegative element from the reaction. Now again it is very important to note here that an reducing agent, after carrying out reduction, itself oxidized in a chemical reaction, just opposite to the oxidant or oxidizing agent. In this reaction, carbon is an electropositive element So when it reacts with copper oxide, it itself reduced, because addition of electropositive element is known as reduction. Okay, and now here the addition of oxygen takes place, which means oxidation. So carbon at the same time it reduced in this reaction and oxidized in a chemical reaction. There are more example of reducing agents. For example, stannous chloride, it is essential to carbon, we discussed here, sulfur dioxide, hydrogen sulfide, carbon monoxide CO, aluminium Al, and nitrous acid, etc. Now the oxidation reduction reactions are complementary to each other. Let's read the theory part. Whenever a substance is oxidized, another substance is always reduced at the same time. Okay. Similarly, when a whenever a substance is reduced, another substance is always oxidized at the same time. For example, a reaction between hydrogen sulfide and chlorine, in which hydrogen sulfide and chlorine reacts to form hydrochloric acid and sulfur. In this reaction, H2S is oxidized to S, which is removal of hydrogen, and the process of removal of hydrogen is known as oxidation, and Cl2 is reduced to HCl, and it is addition of hydrogen, which is called reduction. Okay, so at the same time H2S oxidized to S, and at the same time the another substance, which is Cl2, is reduced to HCl. So the oxidation reduction reactions are complementary to each other. Let's see the more examples. So here a reaction between stannous chloride and mercury chloride takes place, in which SnCl2 is oxidized to SnCl4. Chlorine is electronegative element, and addition of electronegative element is known as oxidation. Okay, just have a look here. Here are only two chlorine atoms, and now here are four chlorine atoms. That means gain of two chlorine atoms takes place. Okay, whereas at the same time HgCl2 is reduced to Hg2Cl2. How? HgCl2 is electropositive element, so here is a gain of one electropositive element, which is reduction. So in the third reaction, a reaction is going between manganese dioxide and hydrochloric acid. In this reaction, the HCl is oxidized to Cl2 because of removal of hydrogen. OX means oxidation. And at the same time, manganese dioxide is reduced to MnCl2. How? Due to removal of oxygen, which is reduction. So now you understand the Oxidation and reduction reactions are complementary to each other. Okay, so redox oxidation reductions are chemical reactions in which the reactants undergoes a chemical change in their oxidation states. So if you don't get it at any point, you can ask freely, doubt on WhatsApp. Just tap here to ask and tap to join our Telegram channel, and you also get this PPT on our Telegram channel. If you still have any questions, you can mail us, you can visit our website and get in touch us with via these social medias platform: Facebook, Instagram, Twitter, WhatsApp, and YouTube. And subscribe to our YouTube channel. Press the notification bell to get instant updates to you. And thanks again. I am Ritik Bhola, founder of InoOP Chem.com.